This is a common piece of equipment used at AlgaeVentures. It's an ultrasonic level sensor, and it is used to detect the water height in the cylindrical barrel. Water escapes this barrel at the bottom through a hole. Using this piece of equipment, chemical engineers like Mr. Rogers find many different relationships between different variables. Today, we'll go through one example, finding the water's flux, or the rate at which the water will escape the barrel per unit area. Our first steps, however, will be identifying the relationships between different sets of variables. All of the equations that we find with the sensor will be functions. This is because the variables share various relationships with each other, such that each individual variable directly affects the other. First, the level sensor is used to illustrate a linear relationship, volume as a function of time. This equation will be used to show us what happens to volume as time goes by. Basically, this shows the water's rate of flow. As you will notice, this equation is written as a quadratic. In this quadratic function, we are accounting for three variables and how they affect one another. 1. We are monitoring the decrease in volume. 2. We are representing the force of gravity. Specifically, we are accounting for the decrease in gravity that will occur as a result of the lowering volume. Lastly, 3. We are accounting for time. Our sensor gives us that quadratic function, which we will also use later. Now, we need to find the volumetric flow, or the change in volume over change in time. This is written as delta V over delta T. And mathematically, this is taking the first derivative. At this point, Mr. Rogers told me, quote, "We find that in our system, it is important to know what the volume flow is when we have a constant water level at 10 centimeters, end quote. In other words, we want to know the flow rate when time is passing, but volume is not changing. It would be nice if we could use our flow rate function, but we can't. We don't know T or V. So in order to find T and V, we need to use the information that we do already have, such as the water height at 10 centimeters, and we want to find volume first. This is the equation for the volume of a cylinder. The diameter of the barrel is 54 centimeters, so the radius is half. Now we solve for volume. It ends up being 22,900 centimeters cubed. That is the same as 22.9 liters. Now we know the volume when the water height is 10 centimeters. And since we now know this volume, we can now use our quadratic function to find time. We plug in our numbers and subtract from both sides. The resulting quadratic at top does not factor nicely, so we use the quadratic formula, which is oh, right. Thanks, guys. So we plug our numbers in the quadratic formula, which is x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now looking at our two results, we can clearly discard the negative 10.2 time value, because we can't have negative seconds. Now we have our appropriate time value of 30.7 seconds. And we now also have both volume and time, so let's plug them into our flow rate equation. The solution is 2.13 liters per second. That is the water's flow when the water level is at 10 centimeters. Now we know the rate at which the water will leave the barrel through the hole in the bottom. What we need to know now is this: how much space is open for the water to travel through? This is a simple area problem. The diameter of the plug hole is 2.54 centimeters. So we plug our numbers into the equation for the area of the circle, or the hole at the bottom. 5.07 centimeters squared is the total area available for water to travel through. Remember, the water's flux is the flow rate per unit area, or liters per second per centimeter squared. 0.43 ends up being our water flux.